transforming linear functions. Alright, so our vocabulary for this lesson starts with family of functions, which is just functions that have something in common. That means either like all linear functions are form a family of functions, all functions with a slope of 1/2 could be a family of functions. Okay, and the parent function is just the most basic one. Okay, so if I have this family of functions that are all linear functions with a slope of 1/2, my most basic one is going to be f of x, since we're talking about a function, all right, equals 1/2 x. Okay, and then the other functions in our family would be like +2, -8. All right, they would be all different, but our basic one, our parent function, would be that one. Okay, moving on to what we'll be doing in this lesson, we're going to be looking at transformations, which is just a change in position or size of a figure. Okay. Today, we're not going to be talking about figures so much. We're going to be talking specifically about lines or linear functions. So the three transformations we have are translations, which is moving something around on the page horizontally, vertically. The idea is that it does not change the shape, or in this case, the slope of our line. Okay, a translation never changes the slope. A rotation is a transformation around a specific point. Usually that's going to be the origin or the y-intercept, and this always changes the slope of a line. Generally, but not always, it'll keep the y-intercept the same. I think later on you'll get into rotating lines and rotating other figures around a point that's not on the y-axis. Reflection is flipping something over a certain line. Again, generally we're going to use the x or y axis, and if we do, it results in one of the variables becoming opposite. Okay, so if we had our graph, our little terribly drawn coordinate plane, and we have our line, we'll say it goes right through the origin, it's just y equals x, then a reflection over the y-axis is going to take all the positive x values and turn them negative, and take all the negative x values and turn them positive. Okay, so it doesn't change the numbers, it just changes them from positive to negative or negative to positive. All right, concept 1, translating linear functions. So when we are moving these functions around, moving these lines around, and we are translating, meaning we're sliding them, we are only going to think about this as a vertical shift, okay, a vertical movement. All right, and we do that because lines go on infinitely. And I want you to take a second and think about that. And if you need to, pause the video, but think about why that would be. Why do we only think about them moving vertically, even though sometimes we might want to move them horizontally, or say that they should go through a specific point, that looks to us like it's 2 points to the left of where the line is. Okay, think about that. All right. So, hopefully you got it. If not, that's okay. The reason why we only think about it as a vertical shift, okay, is because we have access to a really easy, quick, and direct change in our line in our vertical direction. Okay, we have our y-intercept, and if I change my y-intercept, if I take this line is right now y equals x, and I decide that I want it to be let's say I want it to go through this point, which looks to me like it's, well, let's make it even a little more straightforward. I want it to go through this point, okay, on the x-axis. Okay, right now it's going through 0 on the x-axis. I want it to go through -3 on the x-axis. Okay, I could, if I just grab it and move it, I could move it this way and say, oh yeah, there we go, I got it, done. Okay, but it's harder to think about it like that because we don't have direct control. Okay, whereas if I say, okay, how much do I have to move it up to get there? Oh, it looks like 3 up. Well, then that's just going to be a really straightforward change from y equals x to y equals x plus 3, because the whole graph shifted up 3. Because they go on forever in both directions, it doesn't matter if I move my graph, you know, like this, or way up like this. It's still going to go on forever in both directions. Okay? It's not like I'm going to run out of graph on one side, or run out of line on one side. Okay? So that's how we would move our graph to shift to a different point, is by changing that y-intercept. We're also going to be asked to take a line that we have and find find out what we'd have to do to move it to equal another line, or to move it to another position. Okay, and again, we're going to be using our y-intercept, and we're basically just going to count the difference, or subtract the difference between our y-intercepts. Okay, so this has a y-intercept of 0. This has a y-intercept of 1, 2, 3, 4, 5, 6, 7. So what do I have to do? I have to move my graph down 7. Okay, I have to move my graph down 7, or I have to subtract 7 from my y-intercept. And that will change this line to overlap with this one.